If a microscopic organism started stealing energy from our sun, could we really build a ship, cross 12 light years, and stop it? Andy Weir's Project Hail Mary makes that sound almost possible. But if it happened tomorrow, would the science actually work? We already know it's fiction. The challenge is whether the physics and biology underneath could still hold up if one thing, astrophage, were real. So let's assume the microbe exists and test the rest. First, propulsion. The Hail Mary's engines burn astrophage with nearly perfect mass-to-energy efficiency. In real life, even fusion only converts about 0.7% of mass to energy through E/mc2. Weir exaggerated the biology, but kept the physics solid. His thrust math follows Newton's laws and the classic rocket equation exactly. Hand NASA a fuel that powerful, and yes, every trajectory in the novel could actually fly. Now the speed. The ship accelerates at roughly 1.5 g, coasts, then brakes the same way, fast enough to reach about 90% of light speed. That means the trip to Tau Ceti takes around 13 years as seen from Earth, but only about 4 years on board. That ratio matches Einstein's relativity equations perfectly. The time dilation isn't fantasy, it's physics. No warp drive, no shortcuts, just endurance, fuel, and math. What about the microbe itself? Astrophage stores stellar energy, multiplies in vacuum, and fuels an engine. Impossible for known life, but not meaningless. On Earth, radiation-proof species like Deinococcus radiodurans and tardigrades already survive doses that would kill humans instantly. Astrobiologists have modeled ammonia-based and silicon-based life for decades. The concept doesn't break chemistry, it just turns the difficulty knob to maximum. If evolution could somehow bridge that gap, the behavior Weir describes would fit within natural laws. Could such an organism really dim a star? Stars fluctuate all the time from sunspots and dust clouds. Our sun's brightness varies by about 0.1% every 11 years. To cause the kind of dimming in Project Hail Mary, you'd need an astronomical swarm of energy-absorbing material. Implausible. But the mechanism of light absorption obeys pure astrophysics. Radiation would instantly sterilize organic matter, but the math of reduced luminosity still checks out. The cause is fiction, the consequence is real physics. Now the alien partner, Rocky. His species lives in an atmosphere rich in ammonia under crushing pressure, with chemistry built on metals and high-temperature reactions. That is exactly the kind of environment NASA's astrobiology models treat as plausible for non-carbon life. Rocky's infrared vision, his ship design, and his collaborative logic all operate inside real thermodynamics and materials science. It's speculative, not magical. Even the problem-solving feels authentic. Grace and Rocky follow the real scientific method, form a hypothesis, test it, fail, adjust. Their lab procedures, spectroscopy, controlled atmospheres, sealed chambers, mirror genuine research. The Talmiba cure for astrophage echoes actual biocontrol here on Earth, where viruses target bacteria or engineered microbes clean pollution. It's not impossible thinking, it's applied reasoning under cosmic pressure. So, could Project Hail Mary actually work? If we grant one miracle, a microbe that can convert mass to energy as efficiently as astrophage, everything else fits within known physics and chemistry. The engines, trajectories, communication delays, biology, even the time dilation all line up with how our universe truly behaves. No magic, no broken laws, just a single extraordinary discovery driving an otherwise realistic chain of events. That's why Weir's story feels so believable. It stretches science, but it never snaps it. If a light-eating organism ever appeared, humanity would already have the math, the engineering, and the determination to try. If you want to experience the full story, the Audible link's below. And if you'd rather hear my full review of the book itself, that video's right here. Subscribe if you like science that still dares to dream.